Now in this problem we are supposed to design a deterministic push-down automata that recognizes the given language. Now let us analyze the language. L equal to WC W raised to R such that the string W belongs to A comma B the whole star. Now first, before solving the problem, we should analyze what kind of language it is. Okay, suppose W is say A B. Then when I say W raised to R, it means reverse of the string. So if W is AB, then W raised to R, that is reverse of that string, will be BA. Okay, now in the language the valid string should be of the type WC W raised to R. So now when I substitute the value of W and W raised to R, the valid string, one of the valid string that I get is AB. What is AB? That is W. C and BA. What is BA? BA is the value that we have considered W raised to R. Okay, so it means that this is one of the valid strings in the given language. Now let us analyze this string. Okay, the string is AB C B A. Now you read the string from this side. So when you read the string from left to right, it is read as A B C B A. Now you read the string from the right to left. It will be still read as A B C B A. So since when you read the string from right to left or left to right, the string remains the same. You read from this side, it is still A B C B A. You read from the other side, still it is A B C B A. Such kind of strings, they are called as palindrome strings. Okay, now carefully observe, when you count the length of this string, it is 1 2 3 4 5. Okay, the length of the string is odd. So these kind of palindromes are called as odd length palindromes. Okay, now one specific thing that you observe in odd length palindrome is when you read the string, now this C, it happens to be, it's called as middle marker character. It's called as middle marker character. Okay, and we observe that if you read a string W, that is AB, before this C, the string that appears after this C, middle marker character, will be always the reverse of the first term. Okay, so when you consider this particular palindrome string, odd length palindrome string, you can consider it in three parts. First part is the string that is that you can read before middle marker symbol is reached. Now in this example, AB is the string or is the substring that you read before the middle marker character. So this is the first part, first half of the string. Then middle marker character itself is a valid character. So this constitutes of the second half of the string. And whatever is beyond this middle marker character happens to be the third part or third substring of the main string. Now what I am saying is, you observe that before middle marker character, whatever is the string, okay, the reverse of that will be present after the middle marker character. Okay, so we are supposed to design a PDA, deterministic push-down automata, okay, which recognizes this kind of palindrome strings. Okay, now once we have understood what palindrome is and what kind of strings it is supposed to accept, okay, next I want you all to now focus on the strategies that we can use. Okay, now basically what we are using here is a stack data structure, and stack is nothing but it is last in first out, or it is also called as first in last out. What it means is, suppose there is a string, say AB. When you insert this string AB into the stack, A goes into the bottom, okay, and on top of that B is pushed. So you have inserted the string AB into the stack. Now when you are going to read the string, and reading means popping it out and reading it character by character. When you are going to read the string or pop it out, remember the first character that you are going to read is not the one that was inserted first. A was inserted first, but while reading, it is the second character that will be read first. This is the meaning of first in, last out. Whichever character you have inserted first will be read last. So when after inserting the string AB, when you are going to read it back, the string will be read in a reverse way, that is BA. Right? So we are going to take the help of this particular attribute of stack data structure. Having understood the strategy, okay, what I will do is I will take a basic string. Okay, so consider a valid string. Now what logic I am going to use? The logic is very simple. Just see, initially your stack of PDA will have only Z now. So what I am going to do? I am going to push whatever, no matter whether it is A or B, whatever symbols that I obtain before this middle marker character. C happens to be the middle marker character. So whatever symbols that you read before the middle marker character, without hesitation you are going to just go on pushing those symbols one by one into the stack. So as long as you don't reach the middle marker character, what you do is you are going to go on pushing those elements that you have read before middle marker character onto the stack one by one. So with that, first A will be read, right? First A will be read. So you push A into the stack. Then after A, next B will be read. Okay. So then you push B also onto the stack. Fine. Then the pointer is incremented. Now, so I have told you that till the time you reach the middle marker character, you have to just go on pushing. And after this middle marker character, as you go on reading the symbols, you have to just compare and pop those elements. Okay, compare and pop the elements. Now what do I do to this middle marker character? What operation should I perform for this middle marker character? Anyways, this middle marker character is actually not useful to us. It only helps us to know that yes, the first half of the string is over and now the second half of the string would start beyond this middle marker character. So because of that, what we will do is when we read actually the middle marker character, we are simply going to ignore it. Okay, we are simply going to ignore it, but we are going to change the state of the PDA. Earlier it was in a state wherein it was pushing the elements onto the stack. Now once the middle marker character is encountered, we are not going to push it into the stack. Rather, we are going to just ignore it and we are going to change the state to PDA to the new state. And that will be the state wherein PDA will start comparing and popping the elements. Okay, so without wasting time, I'll first manually show you what we are going to do now. Okay, so far till we reach the middle marker character, we have pushed all the elements onto the stack. It has happened. When the middle marker character is encountered, what we are going to do? We are not going to do any operation on the stack. That means there is a no change operation that we are going to perform on the stack. That means B, which was on top of the stack, after the no change operation, B still will remain on top of the stack. What we are going to do is, although C we are going to ignore and the pointer is going to move to the right, but at the same time, suppose you were in a particular state. Okay, suppose you were in a particular state, say Q1. Okay, this state will change to Q2. Okay, so now you know that in Q1 state you are just pushing the elements onto the stack. The moment you are in Q2 state, machine will now perform a different operation, that is comparing. Okay, so I will just do the operation. See, A was encountered, A was pushed onto the stack. B encountered, B was pushed on the stack. You were in a particular state, say Q1. Now when the middle marker character C is encountered, what you do is you perform no change operation on the stack, rather you change the state of the machine. Machine goes to Q2 state. Further, at the end of that operation, again the pointer will move to the next element. Now in Q2 state, when B is encountered, you are going to check the topmost element of the stack. If there is, for this B, if there is a matching B, okay, then this B gets cancelled with this B, as good as saying that this B is popped out of the stack and the pointer gets incremented by one position to the right. Now if A is encountered as the next symbol in Q2, okay, at the end of the operation you are remaining in Q2 only. So if the next element that is encountered is A in the same state Q2, what you are going to do, you are going to check the topmost element of the stack. Is it same? A, yes, it is same. So this A gets cancelled with this A, as good as saying that this A is popped out of the stack and the pointer moves one place to the right. Finally, when there is nothing remaining to be read, that means null is read. Okay, when there is nothing remaining to be read, that time you check what is the topmost element of the stack. If the stack is empty, okay, it means there is no other element that is left to be compared with the remaining string, which also means that all the matching elements were already compared, they were matched and they were popped out. That means there is no unmatched element yet left in the stack. Okay, that means this is a palindrome and it will be accepted. Okay, now whatever method that I have told you, we are going to I am going to draw and show you. Okay, so let's assume that initially the string that is read is ABCBA. This is the string that is read and we are in Q0 state. I am just going to draw PDA for the same thing. Okay, let's say Q0 is a initial state. Now what I do in initial state, whatever elements that we get before we reach the middle marker character, this C happens to be the middle marker character. So till we don't reach the middle marker character, irrespective of whether A or B is read, I am going to just go on pushing the elements onto the stack. Now, also I told you that W, the string W, can be any combination of A's and B's. So that means the current string that I have taken, it starts with A. But other palindrome string can also be like this: BA, C, okay, AB. This also could be a palindrome string. In that string, the string would start with B. So such things also you have to consider. Okay, so we will see both these things. Now, so initially, suppose A is read as the input symbol and that time stack is empty. That means A is the first element that is read in the string. What you do? You push A onto the stack. So the stack will have now AZ1. So if A is encountered as the first input symbol, A will be pushed onto the stack. Okay, A will be pushed onto the stack and the pointer would move to the next element, that is B. But if suppose the string was not ABCB, string was BACAB, which the string actually starts with B. In that case, again the same thing would have arisen. If the first element in the string is B and that time the stack is empty, that time also I would have pushed B onto the stack. So that also I need to write. If B was the first element of the string, okay, and Z0, and the stack was empty, then I would have pushed this B onto the stack. Now why I am writing A, B? Because since W belongs to A comma B, string could definitely start with A or it could also start with B. So if the string starts with A, then this particular transition would work. If the string starts with B, so this is also a palindrome string but starting with B, then the second one would work. Okay, now let's go further. Now let's assume that suppose now for this string, after scanning and pushing A into the stack, let's say we are now reading the next element of the input string B. Then what you do? So if B happens to be the currently scanned symbol and suppose topmost element of the stack is A, then also you are going to push B into the stack, right? Irrespective of what is there onto the stack, if it is B and no matter whether A or B is there in the stack, you are going to just push it. So pushing operation will continue till you don't reach the middle marker symbol. Okay, so now there are 4 possibilities in this case. If B, that is currently read, happens to be not the first element of the string, rather it is some second or some middle element of the string. That time the stack would definitely have some other element. Stack would not have been empty. So when B is encountered as the input symbol, and suppose the topmost element of the stack is A, then you push this B onto the stack. So what you push is the string BA, right? But suppose if it was not B, suppose the next element happens to be A. Okay, now in this case here, after pushing this first B onto the stack, suppose the next element is A. So in that case, if A happens to be the current red input symbol, and suppose B is on top of the stack, then also you are going to push the string AB onto the stack. Okay, now see, the currently red input symbol is B and the topmost element of the stack was A. But it can so happen, suppose the string was BBCBB. This is also a palindrome string. So after reading the first element, B would have been already present in the stack, and now you are reading the second B. Then this B also you will push onto the stack. So that combination also should be written. So if B is the current input symbol, and suppose in place of A, suppose earlier there was B. So for this kind of string, so if B is currently read as input symbol and stack contains B, then what you push inside is BB, right? So all four possibilities, it is BA, AB, BB, and in the same way you can also have a string something like this, AACA. In that case, after reading the first element in the stack, in place of B you would have pushed A, and now that the second A is read, then also this string called as A will be pushed onto the stack. So if A is the current input symbol, just see this case, if A is the current input symbol and suppose on top of the stack there is already A, then this A also you should push onto the stack. Okay, so these are all the possible combinations that will work. So that means no matter whether it is A or B, all these elements you are going to push onto the stack, and you will remain in the same state called as Q0 till you don't reach the middle marker character. Okay, so let's continue. Now when the middle marker character is reached, what you do? When the middle marker character is reached, what you do is you perform no change operation on the stack. Okay, and you just change the state to, from Q0 you move to Q1 state, suppose. Okay, now here also there is some possibility. Just see here, say for this string, okay, say for this string, assume that in the stack already A and B are inserted. So A and B was inserted already onto the stack, and now we have reached the middle marker character. So when the middle marker character C is read, at that time suppose stack contains B, then what you do? You perform no change operation onto the stack. So B which was on top, B still remains on top, and just you go from Q0 state to Q1 state, correct? So if middle marker character C is read as current input symbol, at that time suppose B is on top of the stack, then B will remain the topmost element of the stack. Okay, from Q1 you are going to Q2 state. Q2 is a state wherein you are going to compare them. Okay, now it can so happen that, let's say for the next string, let's say for this string, now for this string, after pushing B and A onto the stack, after pushing say B and A into the stack, first this B is pushed, then this A is pushed. Now when the middle marker character C is reached, okay, in this case of mine you observe that when C is the input symbol which is currently scanned, the topmost element of the stack is A. That time also you will do the same thing. you are going to perform no change operation on the stack. So A, which was topmost element, A still remains the topmost, and you are just going to change the state. The same thing I am going to write. If C is encountered, and suppose A was the topmost element of the stack, then A still remains the topmost element of the stack, and you just go to the next state, that is Q2. Right? So these are two possibilities. Now there is a third possibility also. Okay, sometimes and somebody can give you a wrong string. For example, if the string that is given as input, that is CAB, suppose this is a string that is given as input. Now you know that C happens to be the middle marker character, but in this case the input string that is given to you itself is CAB. Actually this is a wrong string, but if such wrong strings are given, then these strings have to be rejected, correct? So for this kind of string also, let's see what happens. You will be in Q0 state initially. So now C, that is middle marker character symbol, is red. But now what is happening in this string? This middle marker character symbol happens to be the first element. That means first half of the palindrome string is missing and second half of the palindrome string is there. But such string should be rejected. But yes, let's see how PDA tackles this kind of strings. So, okay, third case here is if C is the current input symbol. But in this case, since this is a wrong string, this is not a palindrome string, this kind of string should not be accepted. What has happened when C is currently red? If you happen to see the stack, okay, if you happen to see the stack, since C happens to be the first element of the string, stack would be empty, no? Right? So when C is encountered as the current input symbol, and at that time stack is empty, which means that C happens to be the first element of the given string. It should not be a first element, but suppose somebody has given you a wrong string, then what? So if C, okay, is the first element of the given of any string, okay, and first element means the stack at that time will be empty, Z0. Then again you perform no change operation. That means Z0, which was top of the stack, Z0 still remains the top of the stack, and you are going to state Q2. So for such wrong strings also, you make, your PDA makes a transition from Q1 to Q2. But in state Q2, what you will do? You are going to then do the comparison, cancelling. So that will not happen, and the automata will get stuck into Q2. So for such wrong strings, you will never find the automata transiting from Q2 to a final state. It will always remain to Q2, and then you can say that this string is rejected. But this particular one extra transition I show because such wrong strings also, if they are given as input, then automata should know what to do. Okay, if you don't specify this, then automata would have just remained in Q0 state also. That would also have done, but I am just showing this. Fine. Now let's proceed. So see, before the middle marker character, any character that is encountered, you see all these combinations, we are just pushing them onto the stack. Then when the middle marker symbol is encountered, what we do? We ignore that middle marker symbol and we just move to Q2, the next state. In Q2 state, what we do? We reach Q2 state only after crossing the middle marker symbol. So in this Q2 state, it is very simple. If the currently scanned input symbol happens to be A, you check what is there on top of the stack. If on top of the stack there is A, then they cancel. Okay, that means that A has to be popped out. Similarly, after the middle marker character, suppose the element, the symbol that is encountered after the middle marker character is suppose B, input symbol is B, and top of the stack is also B, then both the B's match and they are also getting cancelled, right? And after doing this cancellation business, finally, okay, in Q2 state, when there is nothing remaining to be scanned in the input string, after reading the entire input string, if the stack is also empty, it means that you perform no change operation and you just go to the halting state HA. Okay, so let us now go for instantaneous description for this palindrome, this particular PDA, to understand better. Okay, so we are going to validate a string. Let's take a string, say AB ABA, C, ABA. Okay, this is a palindrome string. So initially what will happen? Okay, I will use this particular PDA for that. So initially we are in Q0 state. The unread input symbol will be ABA, C, ABA. Okay, and initially the content of the stack is also empty. So stack contains Z0. Now in Q0 state, when first A is read, what happens? You just push that A onto the stack and you remain in the same state Q0. So you will remain in Q0 state. After reading A, what is remaining to be read will be the other part of the string, that is BAC ABA, and that A that was encountered previously, now it resides in the stack. So this is the current content of the stack. Then you are still in Q0 state. Now in Q0 state, if this B is read, what you do? This B, okay, you are going to push again onto the stack and the pointer moves to the next input element and you remain in the same state Q0. Okay, so you remain in the same state Q0. Okay, the B which you have encountered, that you are going to push onto the stack. So the stack current content will be BAZ0, and whatever thing which is remaining to be read will be AC ABA. Fine. Then when the next A is encountered, again you are going to push this onto the stack. So you will remain in the same state Q0. After pushing A onto the stack, what remains is CABA, and at this moment what will be there in the stack is ABAZ0. All this while you are in Q0. Now next you see in the state Q0, middle marker symbol C will be read. Okay, now what happens in the Q0 state? If the middle marker character is read, you perform no change operation onto the stack and you just move to Q2 state, ignoring C. So same thing will happen. Okay, so after this transition, where will you go? From Q0 you are going to Q1 state. Okay, you are going to ignore this C and whatever remains to be read is ABA string, and no change operation is performed on the stack, so stack also will not change, it will remain the same. But from Q0 we have moved to Q1 state. Now next, this is read as input. So now in Q1 state, okay, a small mistake here, I have named this state as Q2, it should be Q1. Okay, please note just the naming which I have done here. This was Q0 state, and this state I had written it as Q2, it is Q1 state. Please make the note. So now in Q1 state what happens? You are going to compare the currently read input symbol with the topmost element of the stack, and if they are matching, then you are going to cancel and remain in the same state. Now you see the topmost element of the stack happens to be A, and the currently input symbol that is read is also A. So after cancellation you will remain in Q1 only. After cancelling A, what remains to be read is BA, and in the stack what remains is BAZ0. Agreed? Next, again when this B is encountered as the next input symbol that is read, in state Q1 again you check the topmost element of the stack and the current input symbol. If they match, cancellation happens, you remain in the same Q1 state. So when you are in Q1 state, okay, after cancelling B, what remains is A, okay, and the stack content now will be AZ0. So what has happened is this B has been cancelled out with this B. So what remains to be read is only A, and what remains to be read is AZ0. Fine. Now again this A is read as input in Q1 state. Again you check whether the input that is read and the topmost element of the stack is same. If yes, they get cancelled and you remain in the same state Q1. So you will remain in the same state Q1. But now after cancelling A, there is nothing that is remaining to be read, so null is read. And after cancelling this A also, what is remaining in the stack is Z0, the token itself. That means stack is empty. Okay, and now in Q1 state, in Q1 state, when there is nothing remaining to be read, at that time if stack is also empty, it means all the matching elements have been cancelled, which also means that before middle marker symbol, whatever was the string, after middle marker symbol, the string which is there is exactly reverse of that string, previous string. Okay, so cancellation has happened. Okay, and nothing is remaining to be cancelled. So this is the time when you go to HA, the halting state HA, which I have written. Okay, by performing no change operation onto the stack. So this is the instantaneous description for the given PD.